In this video, we're going to describe how to boot GRUB using the command line interface. Now I'm going to boot into the system to demonstrate a couple things. There are a few ways that the kernel identifies devices. We're used to looking at devices by their path, dev SDA1, dev SDA2. Now the kernel, on the other hand, may see them a little bit differently. You can see here that our root partition, which is dev SDA2, has actually been assigned a volume name. You can see here the file system also has a UUID. When we're dealing with GRUB, we don't have the device paths available to us to identify the file system. So we can identify the file system by its UUID, and we can also identify it by its volume name, which is synonymous with the label. You can set the label of a file system using the tune2fs command. So I'm going to set our root and our boot volumes to specific labels. That way, when we exit and come back into the GRUB CLI, we can search for these partitions using the label. Now, GRUB, by default, will use the UUID. Those are really long to type out, and it's a very error-prone process. So, for the sake of expediency, know that every place I use a label in the GRUB CLI, you could actually use a UUID. Let's reboot and go into the GRUB CLI. And the first thing I'm going to do is set the pager value to 1, so that GRUB will pause at every screen and give me a chance to read what's there before continuing. Otherwise, we just get tons of scrolling stuff. The ls command provides a lot of information. Right now, what we want to find are the list of bootable devices. So here I can see that we've got one that has been detected by BIOS, and it's got 3 partitions on it. Now the nomenclature here is fairly simple. The HD stands for hard drive, 0 is the number, and it orders the devices in the number found. So HD0 stands for the first hard drive detected on the system, the comma, and then the MS-DOS, and then the number. These identify the partitions and the types. So what this says is that we have one bootable hard drive, it has 3 MBR partitions, and those are labeled 1, 2, and 3. Now because GRUB is able to understand, in other words, interpret and read both partitions and file systems of a wide variety, we can actually snoop around on a file system just by using the GRUB device ID. Now, if I append a path name after that, it actually returns the listing of what's on the file system. You notice the last 2 entries in this list string here are vmlinus and initramfs.img. Now, I've copied the most recent kernel images to those files to save us having to type out the file names. If you have to boot from the command line like this, say something's been messed up, or path names are messed up, or your MBR got overwritten, or your configuration is messed up somehow, this is the process you'll go through to recover. The first thing we need to do is tell GRUB where to find the GRUB information. All of the stuff that's in the /boot GRUB directory, or boot GRUB2. So we're going to set our root. And what this does is it tells GRUB, from this point forward, when I give you a path name, make it relative to this device in this partition. So by setting the root value here, when I do an ls /, you can see that the result is exactly the same as previously when I provided both the drive and the partition name. So our next step is to actually load the Linux kernel. And we tell GRUB to do that with the Linux command. We provide the path name of the kernel. And again, I copy these files from the long version kernel string over to a short one, just for the purposes of expediency. And when we load the kernel, it's very important not to forget that you need to tell the kernel where its root partition is. It sounds somewhat counterintuitive, but if you don't provide the root directive to the kernel, what will happen is that it will take the value as defined by GRUB, and then it won't be able to find the files that are located on the boot partition. Now, this is if you have boot and root on separate partitions. If boot and root are on the same partition, you actually shouldn't have this problem. But here I'm going to define our label, and we labeled our boot partition boot previously. And I realized I just made a mistake. That should have been label root. Okay. Now let's load our init RAM. And we'll issue the boot command. Now, the way GRUB works is that as you issue those commands, they're executed in sequence. So when I issued the Linux command the first time and specified the wrong root label, GRUB went ahead and loaded the Linux kernel and passed that value to the kernel, and the kernel was not able to find files properly. And the system halted. So let's do this again. Let's set our initial root value for GRUB. And now let's load the kernel. Let's load our image file. And let's boot. And you can see everything comes up as we expected. You know how to find the list of devices, and we know how to snoop around on those devices so we can determine which device is which partition. But what if your partitions don't have labels? What if you've forgotten to set them? You can still provide a device path as the root value, but if you get it wrong, of course, the kernel won't boot. Device paths have a way of changing. And that's why GRUB uses UUIDs internally to identify devices. There's a way to search for them, though. You can use the search command, and let's look at GRUB's help for that first. You see here we can search using a variety of methods. We can search by the file system label. We can search by the UUID. So the hint directive tells GRUB what specific partitions it should look on, or gives it ideas as to where it should begin probing around as it's looking for these labels and UUIDs. You'll notice that the set variable here allows you to set a variable name. So let's search for our root partition, and let's provide the same hint that GRUB itself has given us. We believe root is on HD0 MS-DOS 2. And let's look. So you can provide a number of hints. And these have different formats. I encourage you to look at the GRUB documentation. Because we're booting on BIOS, we could provide that as a hint as well. And it returns the right value. Now, if we go back, as we searched previously, One of the things that is great about the search command is that it allows you to set the value of a variable. So if I wanted to set the root variable and I knew I had a label for my boot partition, I could search by the label. I don't even necessarily have to provide a hint depending on the system configuration, and that will set my root variable. Now, if you don't have labels defined, you can still boot the kernel. You have to specify that root parameter, but instead of label, you would use UUID and provide the UUID of the root partition. Now, in this case, I'm going to try to type this out. Hopefully, I'll get it right. And let's load our image. And if we've gotten the UUID right for the root partition, we should be able to boot. All right. Now the question is, how do you find the UUID of the proper partition? And that's where the ls command can come in handy. We can use ls-tac-all, and that will give us for each partition the UUID of the file system. So you notice here that the second partition in this list, partition HD0 MS-DOS2, the label root is clearly shown, but the UUID is specified there, as well as where the partition starts and where it ends. So if you can find which partition your files live on, and I can tell right away, right there, that is the root partition. I can turn around and use ls all, look for the right partition, and find the UUID. Once you've got that information, a label or a UUID, you set your root to wherever the boot directory is located. It could be located on the same partition as your root drive or on a different partition, it doesn't matter. When you set root initially, this value must be the location of your boot directory. So in this case, on this system, boot and root are on separate partitions. Now you can see GRUB builds paths relative to the value of root. If I ls root now, I get a listing of the files back in the root directory. If I were to set root to this value and do an ls, I get my root directory. So let's go through this one last time, and instead of using a label or a UUID, let's use a device name. Now it worked again, but we knew that root was mounted on dev SDA2. Thank you for watching, and I hope you've enjoyed this quick training on bootloading with GRUB. For Linux Academy, this is George Scott.